In GIS, the data management and processing systems, this concept we will understand by question and answers. Which of the following are full-fledged GIS packages? So there are certain options and you have to choose which one of these are the GIS packages complete. So the most popular question is whether Google Maps is GIS or not. You have to answer that. So here are the options: Elvis, GeoMedia, ArcGIS, Corp, and this all of the above. So what do you think is the correct option? The correct option is option number 5, which is all of these: Elvis, GeoMedia, ArcGIS, Corp. All of them are full-fledged GIS packages. Now what is Elvis? Elvis is Integrated Land and Water Information System. The acronym is ILWIS, ILWIS. So Integrated Land and Water Information System is a geographic information system and also a remote sensing software. And this is for both vector and raster processing. That is, in data structure, specifically the GIS data structure, we have vector and raster. Vector is line, point, polygon. Raster is the gridded structure. So what are the features of ILWIS? It includes digitizing. That is, if you have some, say, image, you can mark a road or a land area. Editing, that is, you can cut, copy, paste, merge, export, import, all these facilities. And then comes the analysis. Analysis is very important. That is, you have a data, but in order to have a data analytics, you need to have an analysis result. And the most important part of any GIS is the display of data. From KB till GB, that is the gigabytes of data, we are able to display on it, on ILWIS, because the raster and the vector and the other combined metadata should be able to be displayed. And finally comes the cartography, quality maps. So in any GIS package, cartography plays a very important and vital role. That is art of map making. So production of quality maps is also there in ILWIS. GeoMedia. Now this GeoMedia, the USP of this GeoMedia is that it's a full-fledged GIS package. Actually, it's a Hexagon Geospatial GeoMedia Professional. This is the whole name. Hexagon is the main company, that is the umbrella company, and GeoMedia is one of the product of this company. So this GeoMedia Professional is a geographic information system management solution for map generation. That is different kind of maps. You know that there are demographic maps, there are chloropleth maps, there are so many kind of maps. So it's a complete solution for a complete map generation and the analysis of geographic information with smart tools. And these smart tools are state-of-the-art tools, and I'm talking about the data analytic part. That is why analysis is important. So this GeoMedia provides the analysis of geographic information, and it employs these smart tools for that are capable of capturing and editing the spatial data. Spatial data, any data which has space information, latitude, longitude, elevation or other information which can place it on a globe at the right position, those data are called as spatial data. So capturing and editing is also possible in GeoMedia. ArcGIS. Now this ArcGIS is the Brad Pitt or George Clooney or the Shah Rukh Khan of GIS industry. That is the best software. So this ArcGIS is basically a family of client, server and online geographic information system software which was developed by and maintained by ESRI. Now, as I said, Brad Pitt, George Clooney, Shah Rukh Khan, this level it has in the GIS industry. So this ESRI is the biggest company And you will be surprised to know that the definition given by ESRI is what the GIS definition generally accepted. So this ESRI actually started with the previous ArcGIS, and now it has changed a lot because online things have grown up. Previously it was just a desktop solution, so it was first released in 1982, and this ArcGIS, after released in 1982 as ArcInfo, it was just a command line GIS, DOS. If you remember, in DOS, we used to do everything by command line prompt, like Linux, Unix we do now also. So ArcInfo was later merged with ArcGIS Desktop. So previously it was just a desktop solution, but now it is eventually superseded by ArcGIS Pro in 2015, and right now we are talking about 2024, 2025. So it has grown up as a combined process, a combined GIS package with cloud services, with online services, with web services. So that is how, if you ever go to in any GIS institution, you will see ArcGIS. Now in this full-fledged GIS packages, actually all of these are full-fledged GIS packages: LBS, GeoMedia, ArcGIS and CORP. So the CORP, which is essentially the CAD CORP Spatial Information System, or CAD CORP SIS, you see a registered sign also there. So this is, we will call it as CORP in short. This is an integrated family of geospatial software, and it comprises of everything. What is everything? Desktop solutions, server, web, and also the developer products. So geospatial, geo means earth, spatial means any data having the location parameters in it. So it's an integrated family, just like ArcGIS we were talking about the other day. This CORP is also a kind of that solution, which is a combined desktop, server and web along with the developer products. So if you are in a water resource, say, okay, or you are say in urban planning, so you need a special product. For that you have developer products. So the CAD CORP helps the organization to derive meaningful and actionable intelligence from the data with GIS software, spatial data and services. The whole idea is that you have a data, and if you are able to derive meaningful content or information from it, then the software works. So this CORP gives you that meaningful and actionable intelligence from the data, and it comes along with the space. It works with spatial data, services and GIS software, of course. A GIS package cannot be called full-fledged if the following capabilities are missing. So to answer this question, you have to know the full-fledged capabilities of a GIS package. We are talking about what are missing. The first option is data capture and preparation. The second option is data storage. Can it be called as a GIS package? If it lacks data analysis, can it be called as the GIS package, or the presentation of spatial data is missing? Now I think you are quite aware of all this if you are into GIS field. The answer will be, what do you think? What will be the answer? The answer will be, yes, you guessed it right. It's all of the above. The correct answer is all these are important. Any of these are missing, there is a problem. So the GIS capabilities include data capture and preparation, data storage, data analysis and presentation of spatial data. So spatial data is that data having a location information. So in a GIS package, when we call it as a full capability package, so what do we need to have in it? Apart from the four options you see here, data capture and preparation, data storage, data analysis, presentation of spatial data, you need to have mapping. Okay, so you are into cartography, basically art of map making. Different kinds of map can be made, different kinds of map can be produced. The field of operations, that is, if you are going to a field, say you are taking some laser imprints, you are taking some GIS data, All these can be inputted in a proper format, can be managed, can be handled. And comes the spatial analysis and data science. Now, data analytics is the talk of the town today. So in order to do the spatial analysis, that is, you have a spatial data, you need to have a spatial analysis like the buffering, like there are so many things, analysis, that is the accounting of meaningful content from the data. Data science, of course, playing with data, getting information from the data, and there is immense data. So GIS also, like if earthquake is possible, whether the drought is possible, all these are coming from data science only. And the more important thing is that you are talking about geographic information system and remote sensing. So the imagery and remote sensing becomes very important, right? So if you are getting the data from Iconos or the QuickBird or the Cartosets, you need to have the capabilities of handling these imageries, all these remote sensing data, because different satellite have different formats, they have different way of accessing it, their way of actually analyzing it. And this has to be accompanied by real-time visualization. That is, what you are doing should be seen right now, either it is happening in any part of the world. And of course, getting the data out of it, that getting the analytics out of it. That is, all idea is data is already there, but getting the information out of it, getting the comprehensible output. 2D is on screen, 2D on your paper, but actual world is 3D. So in order to have a great capability of a GIS, you need to have a 3D visualization. And again, even if it is 3D, you need to take out a proper information out of it. And of course, because there is a humongous data, how to manage the data, that is how to input the data, how to process the data, how to output the data, how in a proper format required by your clients, required by the students, required by the examiners, required by the GIS analysts. SDI stands for, now we are talking about this in GIS terms. So this SDI, let us take the options first. Spatial data interface, what do you think is the answer? Spatial data infrastructure, this is the second option. Spatial data intention, the third option. And spatial data international, what do you think? SDI in the field of GIS remote sensing, what is it? Yes, you guessed it right, it's option number 2, spatial data infrastructure. Now the question arises, what is spatial data infrastructure? So this spatial data infrastructure, this term SDI is the acronym for it. This is used to describe the collection of technologies. First thing is the technologies. See, we are dealing with computer science, we are dealing with a software, we are dealing with GIS. So you need to have certain technologies. And you need to have certain policies on that, say, the database management system, or your own policies which comes from the institutional arrangements. So in order to coalesce all these, or we call all of these in a single term, that is the spatial data infrastructure. So let me tell you again, the term spatial data infrastructure is used to describe the collection of technologies, policies, and institutional arrangements that provide a basis of spatial data discovery. So this is all about spatial data discovery. So spatial data infrastructure is made such a way so it enhances or it enables us to have a discovery of this spatial data in the way we want. For example, if you say this data should be accessible only to these people, not to these people. So these are institutional arrangements. You say policy, that is 1 GB of data can be accessed, 5 GB is not possible. Those are the policies being made. So you need to have a database management system which is actually working behind it. So if you combine all this, it becomes a spatial data infrastructure. So spatial is basically the data which has information of the space, that is lat, long, elevation. So you can just put it on the globe where it sticks on it on a globe. So this SDI or spatial data infrastructure is it widely uses the GIS, that is the Geographic Information System. It also uses the GPS, that is the Global Positioning System, remote sensing, And there are other geospatial technologies also. So this SDI is a combined infrastructure of all these technologies which I talked about. And this is all about spatial data discovery or spatial data finding. A data model is a language that allows the definition of. Now, data model is a very specific term we generally use in database management system. So in terms of GIS, Geographic Information System, on the background of any software package, that is the database management system, right? So we are talking about data model regarding to GIS. So what are the options? You have to answer it correctly. So the first one is the structure that will be used to store the base data. First option is this one. The second option is the integrity constraints that stored data has to obey at all moments in time. So first is structure. You can keep it like this. The data can be, say, sequential. It can be, say, hierarchical. It can be in this way, in that way. So these are the structures we are talking about. But there are certain integrity constraints. That is, what are the triggers, what are the events that you need to put in so that the data is handled properly, it is retrieved properly, and there can be data in, say, in the form of image, it can be a vector data, it can be some CSV, comma separated value information. So there has to be some integrity constraints on it. So these all integrity constraints are the rules that the database or data model should obey. For example, in a bank, if you have 2000 say bucks, if you keep anything below 2000, say the bank charges 50 bucks. So this is the integrity constraint. So whenever you are below 2000, the bank will charge you 50 bucks. So that is the integrity constraint. The third option is the computer programs used to manipulate the data. So GIS is basically a computer program. It's a software package. So there will be computer programs. So fourth option is all of the above. Now you tell me what is the correct answer. A data model is a language that allows the definition of what all of these. There are multiple options here. Yes, you guessed it right. It's option number 4, all of the above. So the structures along with the integrity constraints, and on that basis a computer program is made. So this data model is not only for GIS, it's for various other purposes. So if you see a bigger canvas, any business model, it consists of a process model and a data model. So the process model will have processes, it will have application prototypes, all these things. But the data model specifically deal with the data. So you have data, in what form it will be, what will be the logical formation of this, what will be the actual physical formation in which the data will be kept, what will be the data structures in which there will be kept, and how the database will be generated. And that data model, this defines all of these. So the data model determines the structure of data elements within an information system. The data model is all about the structure in which the data elements will be placed or will be kept, if we call it as an information system, because GIS is actually Geographic Information System. It can be a text data, it can be an image data, it can be any other data which a GIS needs. So if you make a table like this, so what will be the relationship between them? Two tables. Tables are generally rows and columns. How the data will be kept and retrieved. So let me make a table here. See, all these horizontal lines or the blocks are rows. The vertical will be columns. So how are you going to keep that data and retrieve that data? That is described by the data model. And then comes the second part, which is data models often display the flow of data through a graph or a data model diagram. So actually from inputting of the data till the storage and then the retrieval of data, all this is in the form of, say, a flow of data through a data model diagram or simply a graph, and that is the data model. So until you are going to make a bridge, you have to make a model of the bridge. Then only you are able to actually go and put concrete and all labor things in there. So you need to have a data model in order to make a GIS system. For example, the ArcGIS have a different data model than the Elvis, right? So we make flow chart, before making a program, a computer program. Similar way, in order to have a database management system, we have to have a data model so that the data model can be made or implemented in a form of a data management system. So the second thing comes here is that the data model is just not data model. People call it as geographic data model. It can also be called as geospatial data, or simply what we are talking about, the question also says data model. So all these are the names for data model only. So a geographic data model, geospatial data model, or simply data model in the context of geographic information system is a mathematical and digital structure for representing phenomena over the earth. So when you make a table, we have a row and you have a column. So what you are actually doing, you are placing the mathematics. Mathematics is what? Metrics, determinants. So metrics was simply rows and columns. So this is a mathematical way. And what is the digital structure? How you are going to keep relationship between these tables? What will be the table 1 will have, table 2 will have? All this is about the digital structure, because you have to convert this mathematics into computer programs also. So this is the digital structure. And basically why we are doing it? We are doing it for GIS. So basically we are doing it for the earth. GIS is all about geography. Geography is all about earth. So whatever is the phenomena happening on the earth, that is mathematically converted into digital form, and that form is described by the data model. So you see here, this is a real world. Now your real world has to be converted into the real world model, which is an analog map. Then we have come to the data model. The data model is now converted into the tables. Which of the following statements is true? So there are certain statements will come, and you have to say whether it is true or false. A table or relation is itself a collection of tuples or records. Each table is a collection of tuples that are similarly shaped. An attribute is a named field of a tuple with which each tuple associates a value, the tuple's attribute value. And finally we have all of the above. But what is the correct answer? Either 1, 2, 1, 2, 1, 2, 3. You got it right. It's option number 4. All of these. Now before we actually go into the tables and relation, etc. Now let me give you an idea of what is tuple, what are records. Now when you make a table, just a table, say in your Word, in your class, in your PPT, whichever you choose, the rows and columns, the table is just rows and columns. So we have 4 columns here. I've made 4 columns. These are all columns here. And these are the rows. Row 1, row 2, row 3, column 1, column 2, column 3, column 4. Now you say there is a name called Ram. This is a person. Now what is the age of Ram? Say 25. Now what is the gender of Ram? Male. And what is the address? Say XYZ. Now this whole horizontal 4 blocks or 1 row is called as tuple or records. What is a tuple? A row in a table, complete row is a tuple. A complete row in a table is a record. For example, Ram is 1 record. Rajni is another record. Rajni, the age is 24. The sex is, or gender is female. Her address is PQR. So we have the second record or the second tuple here. Okay. So the table has rows and column. One of the row, complete row, is tuple and record. And one of the column is simply the attribute, because Ram, what is the attribute of Ram? He is aged 25. What is the attribute of Rajni? She is a female. So all these columns are nothing but the attributes. Whole row, tuple, record. 1, 1, 1, 1 column, they are the attributes. They are the properties. They are the, the metadata. So let us take an example, our actual world example of GIS. You have trees. So we are calling these trees as 1, 2, 3, 4, 5. The first Tree has height 14, the DBH is 26.8, and the species is western hemlock. So this first row is just a tuple. It's a record. Okay. So there is a spatial record, spatial data, because this tree will be somewhere on the earth with lat, long and height, latitude, longitude and height and the elevation. And there are other information also. So the spatial data, how we have converted it into a tabular data, this is how the spatial data is addressed in your GIS systems, in your Geographic Information System database management systems. Alright. So you need to know the table is just row and column. And how we convert the spatial data into tabular data? We make rows. So a tuple is simply a row. A row may have various columns, and all these columns have attributes about a single data, which is Ram or Rajni or tree. And what about the relation? The relation between, say, a Ram and Rajni. They are maybe kids of the same home. How about these trees? 1, 2, 3, 4, 5. 1, 2, 3 have a relation. They belong to a species western hemlock. How about 4 and 5? These belongs to a species called Douglas fir, Douglas fir. So a relationship can be among the tuples, or relationship can be among different tables. The two tables, one of the tables say is telling about the say lat long information of this particular tree. Other table may give all the information which you see here, height, DBH and species. And these two tables can be combined to have a relationship between them. Okay, so it's all about a table, rows and column. One row is tuple, one record, and all these attributes which are simply enhancing or adding up to the data are the attributes. So an individual row or record in a database table, this is each tuple records the value for the columns defined in the table. So each tuple is just the combination of attributes, and this whole attributes in a one row is a record about someone. Like Ram has full record. Which of the following statements is true in connection with a tuple? Now here are certain options here for you. Set of tuples in a relation at some point in time is called a relational instance at that moment. This is the first option. So what is the formation or the content of the table at a particular specific time is the relational instance. See, I'm making a table. There are 3 rows, 3 columns. The rows are called as tuples or records. The columns are called as attributes or information about the main key, primary key, which is the first column, you can call it as. Okay, it's not always. This tuple set is always finite. So when you make a table, you have to feed in what will be the rows and column numbers. So the tuple will always be finite. Remember, it is possible to count how many tuples are there, because in a table you can count the number of rows. So these are nothing but the tuples. These are nothing but the records. So what is the answer? Only 1 and 2 are true. 1, 2 and 3 are true. The answer is correct. You guessed it right. It's 1, 2, 3. All these are correct. Now you understand it like this. So let us understand that in a GIS, it's a basically software. So in order to have a storage, you have to have a database management system. So when you have say a raster data, you have a vector data. Raster data is simply the way you click a picture, and that becomes a geo when you have a geographic information. Same the vector, point, line, polygon. You want to put a text. So all these kind of different data has to be kept somewhere in a GIS system. So these will be kept in some table, and this table combination is database management system. That is, you keep a database of these all geographic data. Then you have a input and output thing, tools or programs that are called the management system. So now you see here, these are 4 rows here. There are columns. So there are 5 columns here. Now all these columns are attributes, and all these rows are tuple or record. So what do you see here? Every row is called a tuple. Every column is called a attribute. So combination of attribute is called a tuple. A combination of attribute is called a record. So tuple and records are same, please remember. And it's a simple row. The table can be bigger as whatever you imagined. But here you see, I'm trying to show you 5 trees. So these trees are actually geographic. They come in geography. But in order to make it as a spatial data kept in a tabular data, we have IDs for them, and every tree is corresponded with the height, DBH, and the species. So how we converted the geographic data into tabular data? Using the tuples, which are the rows, and using the columns, which are the attributes. So tree 1, tree 4, tree 5, whichever you say, has certain height. So that height is the attribute, is the feature of that particular tree. And see, 1, 2, 3 trees, they belong to a separate category species. And similarly, 4 and 5 have different category species, which is Douglas FIR. So the column will only tell one thing, that is the second column will only tell the height. The last column species will only tell species. So in order to have all information about say tree 1, you have to have height, DBH, and species. That's why a complete row is called as a tuple or a record. So an individual row or record in a database table is nothing but the tuple or the information of a single entity. What about the tuple records? It can be tuple or records. They are tagged simultaneously. So each tuple records the value from the columns, which are actually the features or the attributes which is defined in the table. And not only this, different tables are there, and these tables have a relationship between them. So I hope you have a better idea about data management and processing system of GIS through this question and answer. Thank you so much. Have a good one.